What if I told you the concept of infinity could be tangible? That's where hyperreal numbers come in. Welcome to the fascinating world of hyperreal numbers, a realm where the abstract meets the concrete, where the infinitely large and the infinitesimally small coexist. Hyperreals in essence are an extension of our familiar real numbers, but they embrace a concept that has long been considered elusive: infinity. This captivating journey began in the 1960s, when mathematician Abraham Robinson proposed the concept of hyperreal numbers. Robinson, with his brilliant mind, dared to tread where few had ventured. He introduced a new number system that brought the concept of infinity from the realm of philosophy into the world of mathematics, making it a tangible entity that could be used, manipulated, and understood. Robinson's hyperreal numbers include not just the real numbers we're familiar with, but also infinitesimals, numbers so small they're smaller than any real number yet not quite zero. In the hyperreal number line between any two real numbers, there's an infinite number of infinitesimals. A mind-boggling concept, isn't it? Over time, the theory of hyperreals has evolved, morphing and expanding as more mathematicians have delved into this intriguing field. They've developed a rich tapestry of mathematical properties, theorems, and applications of hyperreals, stretching the boundaries of what we thought was possible in mathematics. In the world of hyperreals, infinity is not just a concept, but a number that can be dealt with directly. This has profound implications for many areas of mathematics, including calculus, where the concept of limits, traditionally approached with caution, can be handled in a more intuitive way. So, as we delve into the world of hyperreals, prepare to have your mind stretched in ways you never thought possible. This is not just about numbers, but about a new way of understanding the universe and our place within it. It's about the infinite possibilities that come with embracing infinity. You know real numbers, but what about numbers that are more than real? Welcome to the realm of hyperreals. Now, real numbers are like the bread and butter of mathematics. They're the solid ground we stand on when we count, measure, and calculate. But what if I told you there's a whole other landscape that goes beyond the realm of the real? Enter the hyperreals. The hyperreals are a superset of the real numbers. That means all the real numbers are included in the hyperreals. So what makes them hyper? Well, they also include infinitesimals and infinities. Infinitesimals are numbers so small that they're closer to zero than any real number, but they're not zero. Imagine a slice of pie so thin it's almost non-existent, but it's still a slice of pie. That's an infinitesimal. On the other end of the spectrum, we have infinities. These are numbers so large that they're greater than any real number. Picture a skyscraper so tall it reaches beyond the clouds, beyond the atmosphere, beyond even the farthest reaches of outer space. That's an infinity in the hyperreal world. So how do we get from the real numbers to the hyperreals? Well, it's a bit like building a skyscraper. You start with the foundation, the real numbers, and then you add on the infinitesimals and the infinities, layer by layer. The result? A mathematical skyscraper that dwarfs the realm of the real numbers. But why bother with the hyperreals? What's the point of numbers that are smaller than small or larger than large? Well, it turns out they're pretty handy. They help us tackle mathematical problems that are difficult or even impossible to solve with just the real numbers. They give us new ways to approach calculus, geometry, and other areas of mathematics. So the hyperreals are more than just an abstract concept. They're a powerful tool, a new perspective, a way to push the boundaries of what's possible in mathematics. Hyperreals, with their infinitesimals and infinities, take us beyond the confines of real numbers, offering a broader mathematical landscape. Hyperreals may sound abstract, but they have concrete implications in mathematics and beyond. Diving into the world of hyperreals, we uncover a treasure trove of fascinating mathematical properties. The hyperreals extend the traditional real number line, introducing infinitesimal and infinitely large numbers. This vast extension allows for a more nuanced understanding of mathematical concepts like continuity, limits, and infinite series. In the realm of non-standard analysis, hyperreals play a starring role. Non-standard analysis, pioneered by Abraham Robinson in the mid-20th century, leverages hyperreals to provide an alternative formulation of calculus. This approach offers fresh perspectives on the concepts of differentiation and integration, breathing new life into the age-old field of calculus. But the influence of hyperreals is not confined to pure mathematics. They have practical applications that permeate various disciplines. For instance, they offer a powerful tool for describing physical phenomena. In physics, hyperreals enable us to model processes that involve extremely large or small quantities accurately. Whether it's the vast expanses of the universe or the infinitesimal world of quantum mechanics, hyperreals provide a robust mathematical framework for our understanding. A particularly intriguing application of hyperreals is in the concept of infinitesimal approximation. This technique allows us to approximate a complex function or process using infinitesimals, providing a simpler and more intuitive understanding. Infinitesimal approximation is especially useful in engineering and physics, where it aids in the modeling and analysis of complex systems. To truly appreciate the power of hyperreals, imagine a mathematical landscape without them. We would be deprived of the nuanced understanding of infinity, the fresh perspective on calculus, and the insightful approximations that they offer. Hyperreals have opened new doors in mathematics, allowing us to explore previously inaccessible territories. From physics to pure math, hyperreals have transformed the way we understand and apply mathematical concepts. Hyperreals, like any revolutionary concept, have their share of debates and philosophical implications. The idea of numbers beyond the real, ones that encompass infinity and infinitesimals, may seem absurd to some. Yet these provoke profound questions about the nature of mathematics and reality itself. The philosophy of hyperreal mathematics is a fascinating one. It challenges the very concept of number and size, opening up a realm where quantities can be infinitely large or infinitely small. It blurs the lines between the finite and the infinite, the tangible and the theoretical. This approach, however, is not without its critics. Some mathematicians argue that hyperreals are too abstract, too far removed from the concrete reality of numbers as we understand them. They claim that their use complicates rather than simplifies mathematical understanding, introducing unnecessary complexities. Others, however, see in hyperreals a powerful tool for understanding and modeling the complexities of the real world. Part of the controversy stems from the fact that hyperreals, by their very nature, defy our intuitive understanding of numbers. They operate on a different level, one that can seem strange and counterintuitive. Yet it's precisely this strangeness that gives hyperreals their unique power and potential. Beyond the realm of pure mathematics, hyperreals have found applications in various other disciplines. Economists, for instance, use hyperreal numbers to model economic phenomena that involve large scales or infinitesimal changes. Social scientists also employ them to analyze and predict social trends and patterns. Despite the criticisms, the potential of hyperreal mathematics to provide new insights and solutions is compelling. It's a field that's still evolving, still pushing the boundaries of what we know and understand about numbers and the world they describe. Despite the controversies, the impact of hyperreals on various disciplines is undeniable, making them a fascinating subject of study. As we continue to explore the hyperreal, who knows what other intriguing and profound insights we might uncover? So, what's next for hyperreals? Let's gaze into the mathematical crystal ball. As we delve deeper into the realm of hyperreal numbers, the future is poised with endless possibilities. Hyperreals, with their unique ability to handle infinitesimals and infinities, are set to revolutionize our understanding of mathematics and science. They hold the potential to simplify complex calculations, redefining our approach to problems that were previously deemed unsolvable. The field of non-standard analysis, which heavily relies on hyperreals, is predicted to experience significant expansion. It's expected to deepen our understanding of calculus, providing new perspectives on the behavior of functions and series. The hyperreal framework could also bring about a paradigm shift in areas such as physics, economics, and even social sciences, where it could be used to model complex systems with an unprecedented level of precision. However, as we stride towards a hyperreal future, we must also acknowledge the challenges that lie ahead. The concept of hyperreals, with its departure from traditional real number theory, requires a shift in our mathematical mindset. It demands an understanding of abstract concepts that can be difficult to grasp, even for seasoned mathematicians. Moreover, the application of hyperreals in practical scenarios is still in its infancy, with many areas yet to be explored. Education plays a crucial role in this journey. It's essential to demystify hyperreal numbers and make them accessible to a wider audience. Highlighting their potential benefits while addressing the controversies surrounding them will be key in fostering a better understanding of this intriguing theory. Yet, despite these challenges, the exploration of hyperreals is an exciting frontier in mathematics. They offer a fascinating glimpse into the infinite, challenging our preconceived notions and pushing the boundaries of our knowledge. As we continue to explore the infinite possibilities of hyperreals, one thing is certain: our understanding of numbers and infinity will never be the same again.